Now guys, let me just tell you a small thing here. Ospf. Yesterday we have talked about, say, the theory portions of Ospf, right? Then we have, say, discussed about the working of Ospf, the neighbor table, the topology table, and the routing table, and we did, say, a topology as well, right? Say within the same area we have did the topology. Okay. Now, so yesterday's topology in a single area, and that can be called as intra-area communication. That's called intra-area. Within the area, you have sent the routes. Now, we'll go with the inter-area also. It's simple, not much. Okay, only a very small difference is there. So let me show it to you. So now, suppose let me take the GNS tree and open something. Okay, so let me take, say here, this is the topology here. Let me turn on all the devices. Now, suppose that in this topology, okay, just give me a minute again. Okay, now in this topology, let me tell you, so here consider this as an area. Consider this as an area. Suppose let this be area 0. Let this be area 0. Now let this be area 100. Area 100. And let this be area 200. Area 200. Okay. Now again, what happens is that, say, when we create the Ospf, or when we do the Ospf, R1 and R2, so they will send certain hello packets. They'll send certain hello packets. And when they send certain hello packets, say, I might have told you yesterday that certain condition need to satisfy. If the condition satisfied, they will form neighborship, and they will form adjacency. After forming adjacency, R1 will share the routes to R2, R2 will share the routes to R1. Okay, thereby, say, R1 who knows about the 10 dot network, so then it will be shared to R2, and R2 also knows about this 10 dot network. Clear? Okay. Now again, this is actually an area 100 route. This is actually an area 100 route, and this will be sent through the area 0, and our router 2 will receive it. Okay, so this is from a different area, and this route will be called Ospf inter-area route. It's called Ospf inter-area route. Yesterday we have did the same area. Okay, the same area configuration. When you do the same area, the Ospf will send, I might have told you about the LSU, link state update. So they will send the link state update, or they will send the link state advertisement, and if it is within the area, it is sent as LSA type 1. If it is within the same area, the routes are within the same area, then they are sent as LSA type 1. Now, if it's from different area, then we'll send it as LSA type 3. Clear? 2 for some other thing, which we'll discuss later. Okay. Now shall we check it, guys, or shall we do it? Okay. Yes. So now what we are going to do, so here let me take all the devices. Okay. Now I'm configuring Ospf here. So I've given already I've given the IP address and everything. So here, say, this LAN consists of 10 dot network. Okay, I've already given dot 1 and dot here. Okay, and this is 5.5.5.4.5 here and dot 6 here. Now this is 192.168.200.0, and dot 1 is given in F0/0. It's already configured. Now that only Ospf we need to configure. So now let me go to R1, and yesterday I told you how you can configure the Ospf. We'll go to R1 and we'll go to the config mode. We'll mention the command like this: router Ospf. Then whatever the process ID, you can give, say, you can give any value from 1 to 65,535. Suppose you are giving 500. Okay, then an OSPF instance will be created. Then we'll be mentioning the root. Now we'll mention the roots like this. 5. So network, this is 5.5.5.4. Then for /30, the wildcard mask is 0.0.0.3, and then we'll mention area 0. The yesterday same thing. Okay, so now we'll go inside the OSPF. Then we'll mention the network like this. Network 5.5.5.4, then 0.0.0.3, area 0. Got it? Now the next network. Now this network, it participates in area 100. So what we'll give, we'll go to OSPF, we'll mention the network. The command is network 10.250.100.0, and the wildcard mask here will be 0.0.0.255. And area, what area will give? Exactly, we'll give area 100. Okay, so now we'll go here and we'll give, see the network here like this. So network 10.250.100.0, 0.0.0.255, area 100. Clear? Okay, now exit. Now again, so here let me start capturing the packets. Okay, now in R2 also we'll configure. Okay, so let me go to R2 now, and we'll configure it like this. We'll go to the configure terminal, we'll configure it like this. Router OSPF, suppose 1000. Okay, then we'll mention the network, which is 5.5.5.4. Okay, so here we'll mention the network 5.5.5.4, then 0.0.0.3, and area is 0. Okay, now you can see something. The adjacency has formed. The neighborship has formed, and later the adjacency has formed. Okay, then the next thing, the next network will be mentioned. Say 192.168.200.network. Okay, now you will mention it like this. Network 192.168.200.0, and it is /25 here. Okay, so the wildcard mask is, what is the wildcard mask for /25? Yes, 0.0.0.127. Okay, then area, we'll mention the area, which area it is, 200. This is in area 200, so we'll mention area 200. Clear? Okay. Then we'll exit. OSPF done. Now let me, so I've captured the packets, so let me show it to you, the captured packets. Okay, what happened here? Hello, they have sent. Okay, something happened here, guys, just give me a minute. Okay, yeah, 3 hello packet, but it's not the rest of things, it's not showing. Okay, might be some problem with the, okay, GNS3. So what happens is that, see here you can see the hello packets. Okay, so and after the hello packets, you can see yesterday we have studied about different packets, right? Say then, say they will send the DBD, database description. Then after that you can see the LSR, then LSU, then LS acknowledgement. You can see, you should have, say it should have shown these messages, but unfortunately what happened, I don't know, might be some errors of the GNS3. Okay, so now stop. Yeah, you can see it. Okay, now again, suppose that to view those things, let me just make the interface down. Okay, only to capture the packets I'm making this interface down. Okay, or I'll be giving do show run pipe section Ospf. I'm just say disabling the Ospf. Okay, and then we'll re-enable it. Okay, so no router Ospf 1000. So the adjacency has gone down. You can see this. Now I'm gonna re-enable it. Okay, it's a router. You can see this, the adjacency has come up now. Okay, now again I hope that yes, you can see this. So now it's working. So here you can see the DBD. Okay, so hello packets are sent, then the DBDs, database descriptions are sent. Then after sending, then you can see ls request, link state request, and link state update, and link state acknowledgement. Okay, and if you check the link state update and all, you will find out the networks. Okay, so update packet. So this one, let me check. Yes, these are the networks. You can see 192.168.200.0, and say you can see this network, right? Say let me show it to you. So this is sent by router 2, I suppose. Router 2 knows 192.168.200.network link state ID, or then you can see the mask. The mask is subnet mask is /24. So these are the network information that they are sharing. Okay, now when you take a look at the router, okay, now when you take a look at the router, say R2 we'll check do show IP route. So R2 has got a network 10.50.100.0, and how did he get it? From Ospf. Okay, and IA here, it means inter area. Ospf inter area. It is from this route is from a different area. Clear? Again, when you check the other router, so suppose R1, you will see 192.168.200.network as well. Okay, so now again we'll go to R1, do show IP route, and you can see OIA 192.168.200.0, and they are received it via Ospf inter area. Any doubt? Okay, so this is how you will configure the inter area communication or the inter area routes. Now you don't have to do anything, just enable Ospf and they'll automatically send these things. Now the next thing. Now we'll go on to some other things as well. Okay, Ospf network types. Ospf network types. Okay, now you got different network types, but we'll study only 2 network types for now, okay, which are relevant. So the first thing is called point-to-point network type. Point-to-point network type. Let me tell you about, yes, another one. The second one is called broadcast network type. Broadcast network type. So let me tell you about the point-to-point network type first. Suppose if you have a router R1 and router R2. Now these routers are connected using serial interface, then that is called point-to-point network type. Okay, from a single point to another single point. So that's why it's called point-to-point. Okay, now the broadcast network type, let me tell you an example here. Suppose you got router 1 and router 2. Now between router 1 and router 2, we are connecting them, or we are connecting using the Ethernet interfaces, or suppose fast Ethernet interface. Here also fast Ethernet interface or gigabit Ethernet, with whatever, say those are the Ethernet interfaces. If you connect the Ethernet interface or the Ethernet type interfaces, then that's called broadcast network type. Okay, broadcast network type.
Or if we connected via ISP.
Yeah, ISP also will connect it, right? Say again, OSPF will not be used to connect with the ISP. I've told you, right? Okay. Now, for fast Ethernet, suppose from this fast Ethernet, I can connect a cable and I can connect it to a switch. Then from this switch again I can connect it to another fast Ethernet. The connection is the same, right? Just what I did is I've just connected a switch in between, and the switch is used to extend the LAN, right? Say so far we have been using the switch, and let me just tell you why we are using the switch. If you do not use the switch, then say the router, from the router you can directly connect it to the computer. But how many machines you can connect? Only a single machine you can connect, right? Say directly from the router you can connect to only a single machine. If you want to connect multiple machines, what you can do? You can connect to a switch, and from the switch you can connect to multiple devices. Clear? So switch is used to extend the LAN. That's it. Okay, so here also we have used a switch to extend the LAN. Okay, so that means, say here it is fast Ethernet. So again you can connect multiple routers here. Multiple routers here, R3, R4, R5, etc. Okay, so this is the broadcast network type. So let me show it to you. So if I take the command like this, say, where is it? Yesterday I've shown to you to show IP OSPF interfaces. Okay, it's one command which will show you the interface details, OSPF interface details. And you can see here serial interface is up bar up. Okay, and the network type is point to point. Okay, and see here the fast Ethernet 0/0 is also up bar up, and the network type is broadcast network type. Okay, now there is an issue with the broadcast network type. There is a problem with the,
Show it again.
yes, what happened?
Network broadcast.
Okay, the broadcast means it is like that only. It is named as a broadcast network type. Okay, because see here, if something is sent, then it will be sent to all the routers here, right? So now if something is sent through R1 here, it will be sent to only a single router at the other end, but here it will be sent to everyone, multiple routers. Now, so coming back, so the broadcast network type has got a disadvantage. So now we are going to talk about the disadvantages in broadcast network type and how you can solve them. Okay, so now broadcast network type, suppose let me draw broadcast network type here, say R1 or suppose R3. Okay, because I'm taking R3 because I've already implemented another topology where I have started with R3. Okay, so now you got R3 and now you got some other routers as well, suppose R4, R5, R6 and R7. You got multiple routers here. Okay, and these routers, suppose they are interconnected using a switch. Okay, now the problem is that, so when you implement OSPF in all the routers, in R3, R4, R5, R6 and R7, R3 or all the routers will start sending the hello packets, and the hello packets, it will be received to all the routers, right? Then all the routers will form neighborship or adjacency with each other. Okay, so now here, suppose R3 has sent the hello, it has reached to all the routers here. R4 will send the hello, it has reached to all the routers here. Again, R5 send the hello, it will reach all the routers. So everywhere, everyone will become say adjacency. Everyone will create adjacency with each other. So let me just tell you, R3 will create adjacency with R4, R5, R6 and R7. Now R4, who has already created adjacency with R3, will now create adjacency with R5, R6 and R7. Now R5, who has already created adjacency with R4 and R3, will now create adjacency with R6 and R7. Similarly, R6 also, who has already formed adjacency with everyone, will now form adjacency with R7. Getting it, guys? So how many adjacencies have been formed now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 adjacency has been formed. So the number of adjacency here can be calculated by using an equation n into n minus 1 divided by 2, where n is the number of routers. So that means if you have 5 routers, then 5 into 4 divided by 2, that will give you 10 adjacencies. Okay, what if you have 100 devices, 100 routers? Just as an example, you will not connect 100 routers like this. Just as an example, say if you have 100 routers, then 100 into 99 divided by 2, which will be around, say, 9900 divided by 2, which will be around 4000 adjacencies. Am I right? Okay, I'm not talking about the exact figures. It will be around 4000. Okay, so now the number of adjacencies will be very high, leading to very, say, big, or it will be complex here. Okay, it will lead to greater complexities. Clear? So this is the issue with the broadcast network type. Okay, so you will have multiple adjacencies which will lead to complexities. Okay, now shall we go with the solution?
Yes.
Okay, the solution is that one router will be selected as the leader router. One router will be selected as the leader router. So the leader router, suppose it is R7, and the leader router is called DR. DR, or it's called designated router. What is it called? Designated router. Suppose it is R7. One router is selected as the DR, or designated router. Now one router is selected as backup DR or BDR. Backup DR or BDR. DR means designated router. Backup DR means backup designated router. Suppose it is R6. Suppose it is R6. And the rest of the routers are called DR other. DR others, or it's called DRO. Okay, so how many DROs you have here? So R7 and R6 are DR and BDR respectively, and the rest of the routers, that means R5, R4 and R3, they are DROs. Getting it? So here you got R5, R4 and R3. Okay, now comes the solution. The solution is that DR, so now just give me a minute. Okay, so DR here, I will be drawing it here. DR will form adjacency with all the routers. Okay, again I repeat the word, DR will form adjacency with all the routers. Okay, that means DR, who is R7, R7 will form adjacency with all the routers, that means R6, R5, R4 and R3. Now BDR, that means R6 also forms adjacency with all the routers. So BDR R6 already formed adjacency with DR, which is R7. Along with that, say he will form adjacency with R5, R4 and R3. Now the condition is that DRO to DRO neighborship, DRO to DRO adjacency will not be formed. Getting it? DRO to DRO adjacency will not be formed. Clear? So this is also DR will form adjacency with everyone. DR will form adjacency with BDR and DRO. Now BDR will also form adjacency with say DROs. Now DRO to DRO adjacency will not be formed. That is the special case. Clear, guys? So now suppose R, so how many adjacencies are there now? 1, 2, 3, 4, 5, 6, 7. 7 adjacencies. Previously it was 10 adjacencies. Now that we have decreased to 7. In case of 100 routers, suppose one router is the DR. Okay, so this one DR will form adjacency with everyone. That means he will form adjacency with 99 other routers. Now this BDR will form adjacency with 98 DROs or 98 other routers. So how many adjacencies are there now? 197, I suppose. Okay, so previously it was around 4000 adjacencies. Now that you have significantly reduced the number of adjacencies to 197. So this is the case. Clear? Okay. Now, shall we do it? So this is the solution. This is how you will reduce the number of adjacencies. Okay. So now let me take another topology here. Yes. Don't consider this router for now. It is to be used for something else. Okay. Yes. Now guys, this is the broadcast network type. Okay, and here you can see R3, R4, R5, R6 and R7. Okay, these are the routers. Now, so let me turn on all the devices and implement Ospf. Okay, here this is a network, right? So here this is a single network, and here I've assigned the IPs 10.0.0.3. So for this router I've assigned the IP 10.0.0.3. For this router I have assigned the IP 10.0.0.4, 10.0.0.5, 6 and 7. So the network address here is 10.0.0.0/28. Okay, now so here I'm gonna do the Ospf in all the routers. So now what I'm gonna do is I'll go to the routers, we'll implement this command. Router Ospf suppose 100, then the network is say 10.0.0.0 and it's /28, so it is 0.0.0.15 and area, let it be area 0 itself, area 0. Okay, so now let me go to all the routers here and enable. Enable config. Okay, just give me a minute again, guys. Okay, now one more thing. Okay, so now we'll see what happens. Okay, now that we have say implemented the OSPF, okay, shall we check it? Okay, so now then I told you, so R7 will become the DR. R7 will become the DR. Let us check. Okay, so let us check R7. R7 do show IP OSPF interface brief. You can see, yes, it will take some time. Or do show IP OSPF interface. Here you can see, yes. Okay, interface PR. So here fastnet 0/0 is participating in OSPF, and the status, what is the state? DR. The status DR. Okay, now again, if you have the command do show IP OSPF interfaces, interface, which interface it is? Fastnet 0/0. If you give this command, you can see fast Ethernet 0 is up bar up. Okay, and you can see it is the broadcast network type and the status DR. So it has become DR. R7 has become the DR, and you can see the backup. So the designated router ID at the DR ID is 10.0.0.7, which is R7. Now BDR ID is 10.0.0.6, that is R6. Now you can see, yes, the neighbor count is 4 and the adjacent neighbor count is also 4. That means he has formed neighborship with 4 people and he has also formed adjacency with 4 people. Who are those routers? 10.0.0.3 R3, R4, R5 and R6. R6 is the BDR, backup designated router. Clear? So again, if you take the neighbor table, do show IP OSPF neighbor, you can see, yes, 10.0.0.3 with R4, with R5 and R6, he has formed the full adjacency. Okay, and R6 being the BDR and R5, R4, R3 being the DR other. Clear? Now, if you take a look at R6, if you take a look at R6 now, do show IP OSPF interface brief. You can see R6 has become the BDR. Or do show IP OSPF interface fastnet 0/0. Here you can see, yes, R6. Say now the DR ID is 10.0.0.7. That means R7 is the DR. The BDR ID is 10.0.0.6. Here you can see the state is BDR. And one more thing you can see, the neighbor count is 4, adjacent neighbor count is 4. That means he has formed adjacency with 4 routers, R3, R4, R5 and R7, who is the DR, designated router. Clear? Again, getting it, guys? Yes or no?
Yes.
Srikanth, where did you go? You could have asked me, right?
Yes, sir.
Okay. Yes, Srikanth, say there you are okay, but here we got another Srikanth who is again. What happened? From which portion you want me to explain? Adjacency. Simple. Nothing. Say this. Say, did you get what the DR, BDR and DR is? Okay. Did you get what I explained it in here? This one. The solution and all. Got it? Okay, the same thing. I just explained the same thing. We have just implemented the same thing here and I'm just showing it to you. That's it. Okay, so here in the figure I told you, say BDR will form adjacency with everyone. Right? BDR, who is R6, will form adjacency with R7. Okay, will form adjacency with R5, R4 and R3. The same thing I'm just showing it to you. Okay, so here R6 you can see, which is the BDR. Where is it?
Sir,
Yes.
in the picture, can you just show me the topology?
Of course.
Yeah. So in this picture, what we are meant to actually resolve the problem of authenticated route, right?
We didn't talk about any authentication now.
No,
Maybe.
not that authentication. I'm talking about suppose we are configuring one single router as a DR, okay, so that DR can send all the valid routes to the other members, right?
Yes, but we
So that kind of authentication I am talking about.
yes, of course that happens.
So we are resolving this problem. Otherwise, what happened if any router is telling this route is invalid, some other router will say no, this is currently available through me. So like that way, only that DR router, if they say this route is valid, then all the routers should update their routing tables accordingly to DR updates. And if the router is saying this is not valid, then they will update accordingly. So this is the scenario, right?
Yes, of course. The DR will be acting as the main central point here.
Yeah, communication for all communication, right?
Yes.
And if the DR goes down, then the BDR will take up the...
And that part we haven't discussed. Okay, I'll come to those part now. Okay. Now, Srikanth, so we were discussing about, say, this BDR. Okay, BDR. So the BDR, say, which is R6. So he will form adjacency with everyone over here, which is R3, R4, R5 and R7. Getting it now? Okay. Now if you take a case of any other router, suppose R3, which is a DRO. Okay, which is a DRO. So here you can see, say R3, I have written it as a DRO. So here R3 is a DRO. Okay, so if when we take R3 and when I execute the command do show IP Ospf interface brief, you can see it is DR other. Okay, now and again if I execute the command do show IP Ospf interface fasten and 0/0, you can again see, say it is the status DR other. And again you can see here the neighbor count is 4 and the adjacent neighbor count is 2. Neighborship he has formed with all the routers, but adjacency he has formed with only 2 routers. Which are those routers? 10.0.0.6 and 10.0.0.7. 10.0.0.6 means the BDR and the 10.0.0.7 is the DR. So the DRO only formed adjacency with 2 routers, which is the BDR and the DR. Clear?
Sir,
yes.
Again, one small doubt.
Yes, please.
So when R3, making 4 adjacency, okay, with all, neighborship.
Okay.
R3 will make neighborship to all routers, right?
Yes.
But only adjacency is having their router and their BDR router, right?
Yes.
So that means R3, please correct me if I am wrong, R3 is with full sync with DR and BDR.
Yes.
But only the limited information they will exchange with other routers, right?
Of course. They'll only send certain hello packets. That's it. Okay. If it's a neighborship, I've told you yesterday, right? So if it's a neighborship, then they will only say exchange the hello packets. After exchanging the hello packets, they'll form the neighborship. That's it. After that, they'll not continue with, say, sending the, say, LS, say, the DBDs or LSR or whatever it is. Okay. So once they form the adjacency, or say if they have sent it, say, then they'll form the adjacency. So if they form the neighborship, then only the hellos are sent here. Clear?
I think he is confusing how R7 or R6 become DR or sorry.
No, we was just talking about, okay, I'll tell you that. Okay, but say those things we'll talk about it a little bit later. Okay, of course, how did R7 become the DR and how did R6 become the DR, we'll talk about it a little bit later. Okay, now so coming back here, R3. So again, if you check do show IP Ospf neighbor, when you check it, you can see, say R3, it has formed adjacency with R6 and R7, which are, say, BDR and DR respectively. And with R4 and R5, he has formed two-way neighborship. He has formed just two-way neighborship. Okay. So this is how the broadcast network type, the OSPF will work in the broadcast network type. Any doubts? Okay. Now, let me tell you. Now that we'll talk about how R6 and R7 became the DR and or the BDR and DR respectively. Okay. So R7 here became the DR because the DR here in the broadcast network type, they'll share the hello packets and all. Okay, and then R7, or say they will send the hello packets, everyone will share the hello packets, then everyone will receive these hello packets as well. Then R7, who is having, say by default the DR will be chosen based on, by default the DR will be chosen based on a value called router ID.
Which is higher.
Yes, the router with the highest router ID will become the DR. Okay, I didn't tell you what is router ID. We'll talk about it again a little bit later. Now just understand, DR is the router. Okay, DR is the router which is having the highest router ID value. Okay, again that is the second condition, guys. Again in front of that we still have one more condition. Okay, the condition is that the DR router is a router which is having the priority, the highest priority. There is a value called priority. Okay, the router which is having the highest priority number will become the DR. And by default the priority of all the routers are 1. By default the priority of all the routers are 1. Then if the priority is same, then they will be checking on to the router ID. Whoever is having the highest router ID will become the DR. Getting it? Now let me show the priority to you. So the R7, okay, or suppose R3. When I take R3 here, show IP Ospf neighbor, you can see a value pri or priority. This is the priority. So everyone has the priority 1. By default all the routers has the priority of 1. Then they will check on to the router ID, say for each router for R3. Show IP protocol is the command to view the router ID. Okay, if you view the show IP protocol, you can see for R3 the router ID is 10.003. Okay, for R4 do show IP protocols. The router ID is 10.004. For R5 do show IP protocol. The router ID is 10.005. For R6 the router ID is 10.006. Okay, yes, the router ID is 10.006, or do show IP protocol. You can see the router ID is 10.006. And for R7 the router ID do show IP protocol, it is 10.007. So I told you that here for R3 the router ID is 10.003, here the router ID is 10.004, here the router ID is 10.005, here the router ID is 10.006, and here the router ID is 10.007. So DR is the router which is having the highest priority. And what is the priority of all the routers by default? It is 1. Then as it is everything is same, or all the priority values are same, then they'll check on to the router ID. Okay, who is having the highest router ID, guys? 7. R7 is having the highest router ID, 10.007. Whereas R4 is having only 10.004, R3 is having 10.003, etc. So that is how, yes, so that is how R7 became the DR, because of the highest router ID. Now the router with the second highest router ID will become the BDR. Clear? Any doubt?
If I want to change priority value.
Yes. If you want to change the DR, if you want to change the DR, you can configure the priority. You can configure the priority. I told you, say the router with the highest priority will become the DR. Okay, so now if I change the priority of R3 to 2, who will become the DR? R3 will become the DR. R3 will become the DR because of the highest priority. Who will become the BDR? R7 will become the BDR. R7 will change its state from DR to BDR because say the highest priority is with R3. Okay, and the BDR will become, or sorry, R7 will become the BDR because, not because of the highest priority, because of the router ID. The highest router ID is for R7, so he will become the BDR. Clear? So now, shall we change the priority?
Yeah.
So let me change the priority of R3. So we'll go to R3 now. Then to change the priority, what I'm gonna do is I'll go to the Ospf, or I'll go to that interface. Okay, so interface fastNet 0/0, then we'll mention the command IP Ospf priority. Then I'll give the priority as 2 here. Okay, IP Ospf priority 2. Then again what I'm gonna do is I'm gonna rerun the SPF algorithm.
What is the command to rerun?
To rerun the SPF algorithm, the command is clear IP Ospf process. Then you need to confirm it, or do clear IP Ospf process. Okay, now you can see now in R4, when I take R4, do show IP Ospf neighbor. Okay, who has become the DR? R3 has become the DR. Why R3 has become the DR? Because of the highest priority. Now who is the BDR? R7 is the BDR because he has got the highest, say, read value or the router ID value. Clear? Okay. Now again, so what happens is that now R3 is the DR, R7 is the BDR. Now if R4 has got some networks here and R5 has got some networks, and R6, R7, R3, everyone, if they have got some networks, what they will do is that they have formed adjacency with DR and BDR. So all these routes will be shared to DR and BDR. They will be sharing all these routes to the DR and BDR. So what happens is that they will share these routes. They will share these routes to DR and they will share it using the destination IP 224.0.0.6. 224.0.0.6. Okay, now yesterday I told you that the routers will start sending the hello packets. So the hello packets are sent using the destination IP 224.0.0.5. Getting it?
Yeah.
Okay, let me again show it to you here. Unfortunately, I've closed it. You can see. So the routers are sent the Ospf packets. These are the Ospf packets. Ospf. So the routers are sending the hello packets, and the hello packets are sent to the destination, or the packets, the Ospf packets are sent to a destination 224.0.0.5. This is the destination multicast address. Okay. Now the DR. Suppose the DR comes to know about a route. Okay, so suppose R5 is configured with a LAN 1.1.1.1 slash or 1.1.1.0 slash 24. Then R5 will send this route information to whom? To DR, R3. Okay, so then this network information will be sent using the destination IP 224.0.0.6. Shall I show it to you? So now let me create a network here. Let me create a virtual network, a virtual interface, which is called loopback interface. Shall I?
Yeah.
Okay, so they are getting it. Okay, so now let me go to R5, create a loopback interface, a virtual interface like this. Interface loopback, suppose 100. Any number you can give. It's a virtual interface, and you can see the loopback interface, the virtual interface has come up. Then let me give the IP address, suppose 1.1.1.1 slash 20, say 32. then 255 dot 255 dot 255 dot 255. Okay, now if you take do show IP interface brief, you can see a loopback interface with an IP 1.1.1.1. The loopback means it's just a virtual IP. It's used for testing purpose and all. Okay, now so here if you want to send this, okay, you need to participate in Ospf. Okay, you want to participate this in Ospf. So shall we participate that network in Ospf?
Yes.
Okay, so again, just give me a minute. Let me capture the package. Stop capture and let me capture it here. So yes, so I'm gonna make them participate. So let me go to R5 and let me give the command router ospf 100, then let me give the command network space, say 5 dot, sorry, it's not 5, it's 1.1.1.1. It's /32. So what will be the wildcard mask? 0.0.0.0, because say 32 here means all the 32 bits are network. So network portion will be made zeros. So 0.0.0.0 will be the wildcard mask. Then we'll give the command area, suppose area 0. Okay, then what happens is that, say I told you R5 will send this information to R3. Okay, using the destination multicast address 224.0.0.6. I can show it to you. Suppose let me take Ospf. Okay, yes, you can see R5 has sent something. Say here R5 has sent something to, here you can see R5, this is 10.0.0.5, which is R5. R5 has sent something to the destination 224.0.0.6.
Why this and 6?
Sorry?
Why this and 6 multicast IP?
Why this? Why this means, say it is sent to the DR. So everyone needs to know it is sent to the DR only. So DR only will accept it. Okay, so DR only will accept it because it is sent to DR only. Nobody else should accept. Okay, so we are sending it to the group now. Okay, here also you can see, say 224.0.0.5. That means even though if some other machines receives it, they will say ignore it, because 224.0.0.5 is reserved for Ospf, and if at all somebody receives it, then they can ignore it. Okay, yes. Now, so here you can see the ls update packet, and when you check it, you will have the network address. So this is LSA type 1 because it's in the same area, and you can see this, say 1.1.1.1. You can see this. So 1.1.1.1/32, and the metric is, or the coast is, this is the coast. Okay, so this is how they will send the network information. Okay, and then you can see, then say all the routers are sending it. Say again, what happens is that R7 then will send this route to all the routers. R7 will send this route to all the routers. That means, sorry, not R7 guys. Okay, R3, not R3. Yeah, here. R3 will send the update here. R3, who is the DR, will send the update to everyone. Getting it? So it is, say, as if, so we got the R3 who is the DR, who is the leader router. So in case of any update or anything, all the routers will send these information, the update or whatever it is, they'll send it to the DR. And the DR, what the DR will do is that DR will send it to the rest of the routers. DR will send it to the rest of the routers. Clear? And that's what even Srikanth also just told some time back. Okay, so DR is responsible for, say, everything. Okay, so all the routers here will contact DR for anything and everything, and then they will acknowledge back. Clear, guys? Okay, now if the DR goes down, then the BDR will take over its place. If the DR goes down, then the BDR will take over the place, and BDR, the new BDR will be some other router. Clear? Okay. So this is how the OSPF works in the broadcast domain. Clear? Any doubt? Srikanth?
Where we use it? LAN, CAN or WAN? OSPF.
OSPF, you can say WAN you will use it, because of course,
You told the ISP is not working.
so that is again ISP, that means internet, it is connected to the internet. Internet connection and WAN connection both are different. Okay, internet connection and WAN connection both are different. So when you go to the internet, that means you are using the public, say,
WAN means geographic location.
yes, WAN here means, say suppose if these branches are connected, say separately, say suppose branches are located geographically, they are separated, then you will go for something called the WAN connection, and in the WAN connection you will be sharing these networks only. Getting it? Whereas say these networks, in the sense whatever the branch it requires, they will send those network. Clear? Okay. While the internet is something else. Internet means, say if it's say you are connecting it to Google, you are connecting it to Facebook, that is not part of your network. That is somebody else's network. So you are connecting to internet, or you are connecting to some other.
How we connected WAN?
Sorry?
How we connected WAN?
How we connect to WAN? Okay. Yes, we connect to WAN. That's, I suppose I might have told you, right? Say how we connect to WAN means we will say go to service provider. Okay, it is, so we'll not call it as internet service provider, we'll call it as WAN service provider. Got it? Okay. So now I suppose everyone got it. Okay. Now need a break, or shall we go with the next one?
Go with the next one.
Break. Okay, can give you a break, no issues. So we'll get back at 9:11. Okay, we'll try to complete the OSPF today itself if possible. Okay, or else by tomorrow we'll complete it.
And what about the lab?
Lab, you guys will do it, no worries. Okay, so the lab usually I'll give it after, if you want I'll give it tomorrow or day after tomorrow. Usually I'll be giving the lab after the CCNA classes. Once we complete all the topics, then you can go with the, say, lab. Okay, now that you are already doing these things, the configurations in the packet tracer or in the GNS3, and only difference is that, let me tell you, the only difference is that you will be connecting it physically. Okay, that I'll be making you do once we have completed all the CCNA portions. Okay, yes. So now let me give you a break till 9:12. Okay, yes.
Bharat sir.
Yes, guys.
Bharat sir, Srikanth.
Yes, Srikanth. Tell me.
Can I discuss one small real life problem?
Sorry, small?
Real life problem.
Real life problem. If it's your work related, then we can discuss after the class. Is that fine?
Okay. Okay, sir.
Okay. So guys, a little more say extended up to 15. Okay, just I'll be back now. Yes guys, I suppose now we can start. Right, now we'll talk about the router ID. So you can write the heading router ID. Router ID. So I told you the router with the highest router ID will become the DR by default, because the priority is same for everyone. Right, now the router ID here, what was the router ID for R3? It was, or what is the router ID? 10.003. And what is the router ID of R4? 10.004. Router ID of R5 is 10.005, R6 10.006, and R7 10.007. You feel, or you might feel familiar, right? So I've told you the IP address that I've given here is 10.003 for R3, and the IP address that I've given here is 10.004 for R4. Say similarly for R5, R6, and R7. Sometimes, of course, sometimes the IP address can be the router ID. Okay, so actually router ID is a value with which you will differentiate the routers. Okay, so now we humans can differentiate with these numbers R3, R4, R5, R6, and R7. But the routers cannot differentiate the routers based on these values R3, R4. R3, R4 and all, it is just the host name. It is just locally significant, and that too, that is not used for any other purpose. In the OSPF, it is not at all considered. The host name is not at all considered. So I told you that R5 is sending 1.1.1.1 network, right? So R5 is sending it to R3. So when R3 receives it, R3 understand it is sent by R5, not because of this host name, but because of the router ID. Getting it? So router ID is a value with which they will differentiate the router, and it's a must that the OSPF routers need to have the router ID. It's actually a 32-bit value. The router ID is a 32-bit value written in IPv4 format. It is written in IPv4 format. Okay, now say the router ID can be manually set. You can set the router ID manually. Okay, so the router ID can be set manually. We haven't set the router ID manually. Okay, if we haven't set the router ID manually, then the router will look for the loopback interfaces. The router will look for the loopback interfaces. The loopback interfaces, I told you, these are virtual interfaces. You cannot see it with your eyes. These are just logical concept. Okay, so it is used for testing purpose. Here also I used it for testing. The same thing. Here I have created it and I have shown it to you. What happens here? Right, that's the testing. So it is, the loopback is used for testing purpose. So it will check for the loopback interface, and the loopback interface IP address will be set as the read value or the router ID value. Clear? Everyone? Ritik also getting it? Now the third one. So previously we haven't set the loopback address also. Right. So first the router will check whether the router ID is configured manually or not. If it is not manually configured, then they will check for the presence of loopback interface. If the loopback interface is not there, then they will check for the physical interface. They'll check for the physical interface. Physical interface, of course, they will have an IP address. Right. So if at all you got multiple IP addresses for, say, the IP address for multiple interface, the highest IP address will be selected as the read value or the router ID value. Getting it? So here, how did they select the router ID as 10.003? First, they have checked whether the manual read value or the manual router ID is set or not. We haven't set the manual router ID. Then they will check whether any loopback interface exists or not. In R3 we have not created any loopback interface. Then they have checked the physical interface IP. So the physical interface fastnet 0/0 is having the IP 10.003, and this IP is made as the read value or the router ID value. Clear? This is how the router will select the read value. This is how R4 will also select the read value. This is how R5, R6, R7, all the OSPF routers, this is how they'll select the read value. Once the read value is selected, then if it is in a broadcast network type, then they will select the DR based on either the priority, or if the priority is same, then they will select the DR based on the read value. Clear? Everyone fine? Okay, so this is the concept. Now, so here R4, you know, 10.004 is the read value. Now, to change the read value, what you need to do is that you will go to R4. You will go to R4. You will go inside OSPF. Okay, so router OSPF 100. We'll go inside the OSPF and the command is router-id, then you will give the router ID. Suppose I'm giving the router ID 11.11.11.11, some random router ID. Okay, and now after we change it, it is telling us to reload or use clear IP OSPF for this to take effect. That means, say they have already selected the router ID. Okay, now for the new router ID to take effect, you will have to reload the OSPF or rerun the OSPF SPF algorithm. The command is clear IP OSPF process. In all the routers we need to do now here, because then only you will get it. Okay, so again let me, yes, okay. Now that, let me just tell you now. So then what is the router ID of R3? Have we changed it? No, the router ID is 10.003. Now what is the router ID of R4? 11.11.11.11. How did it become 11.11.11.11? Manually we have given it. So when you rerun the SPF algorithm, the OSPF will check whether any manual router ID is set or not. If the manual router ID is set, then that itself will be the router ID. They will not further, or they will not proceed further. Clear? So the router ID is chosen as 11.11.11.11. Then what about R5's router ID? It was 10.005, and R6 router ID 10.006, and R7's router ID was 10.007. Okay, now we'll check it. Just a moment. So when we go to say R5, do show IP OSPF neighbor, you can see yes, of course, 11.11.11.11. Okay, there's one mistake here which I'll tell you a little bit later. Okay, now so the 11 dot, so R4 the router ID has changed to 11.11.11.11. Okay, now guys, now again one more thing. Now just give me one more minute. Okay, now so this is the router ID. Now with respect to the router ID, or say who will be the DR here? With respect to router ID, if I am talking, R4 will become the DR, because say when we consider the default priority, all the priorities are 1 by default, but in our case we have changed the priority of R3 to 2, right? So DR will be R3 itself. DR will be R3 itself because of the highest priority. Now who will be the BDR? R4 will be the BDR. And how it became the BDR? Yes, highest router ID. Okay, so here we have changed the BDR because say R4 has become the BDR because the priority is same. Then they have checked the router ID. Say the highest router ID is with R4, so R4 will become the BDR. Okay, so now we'll check it. We'll go to say suppose R5 and do show IP OSPF neighbor. Okay, so still they need to calculate it, guys. Just give me one more minute. It may take some time for them. Yes, so now when you check it, do show IP OSPF neighbor, not yet. This is the DR. Just give me a moment, guys. Again, just give me one more minute to show IP protocol, no, to show IP OSPF interface brief. Cost to show IP OSPF interface include priority. Priority is 1 only, but he is the DR. Just give me one more minute, guys. It might have. So we have configured R3 here. Sorry. Yeah. Now only the interface has come up. What happened? I don't know. This interface changed to down. Just give me one more minute. So what happened was, unfortunately, that R3's interface went down. Okay. Now that after some time, you can see R3 will be DR and R4 will be the BDR. Okay. Yes. Up only. Okay. So now yes, they are selecting it. It will again take time. There are OSPF timers and all, so it will take some time for them to select the DR, BDR, those things and all. Yes. So now when you see R3 is the DR and yes, R4 has become the BDR. Clear, guys? This is the OSPF. Okay. Now we are almost come to the end of OSPF. After explaining 2 or 3 things, we'll now wind up the OSPF. Okay. Now the next thing is that now I told you the cost will be calculated by using an equation, right? The equation is cost is equal to reference bandwidth divided by interface bandwidth. Of course, they will calculate the cost by this using this equation by default, or else you can define your own value. You can define your own value. You can say to the OSPF. So here, the cost here. What will be the cost here, guys? Say the equation is reference bandwidth divided by interface bandwidth. The reference bandwidth is 100, and the interface bandwidth here. What is the interface bandwidth? Is it 100? So the Ethernet here, it works at 10 Mbps, and fast Ethernet works at 100 Mbps. So the link will be working in 10 Mbps only. So the interface bandwidth is 10. So the cost will be 10 here. So let me show it to you. So suppose if I take R4 here, or suppose R4. Do show IP OSPF interface brief. Okay, you can see the cost is 10. Now, if at all you want to calculate, or if at all you want to give your own cost, you can give it. So what you're going to do is you will go to that interface. You will go to interface FA 0/0. Then you will mention, you can manually define the cost by using the command IP OSPF cost then the value you will mention. Whatever value you want, you can mention. Suppose if I mention 100, then the cost will be 100. Okay, 100. So then do show IP OSPF interface brief. You can say it was previously 10, it is now changed to 100. So this is how you will change the cost value manually. Got it? Now the next config. Now I told you, if you want to enable the OSPF, you will go to the router and you will define the command like this: network space 10.0.0.0, then 0.0.0.15, then area ID or the area 0, you have defined it. Okay, or suppose if you have another LAN here and this is fastnet 0/1, then you will go to FA0/1 and you will define the command like this: network, suppose the network is 20 dot, or suppose 80 dot, suppose 80.0.0.0/24. Then the command is network 80.0.0.0, then the wildcard mask is 0.0.0.255, then suppose it is area 0, you will give area 0. When you define this command, two things happen. The first thing is that this network will get advertised to the DR, or whoever is the router, it will get advertised to the other router. Clear? That is fine. The second thing is that through this interface, they will start sending the hello packets. Through that interface, they will start sending the hello packets. Now, it's actually a LAN, local area network, where the end devices are connected. Do we need to unnecessarily send the hello packets through this interface? No. So these are, say, the hello packets are sent so that, say, so to find out the neighbor routers and they'll form the neighborship. If you do not have any routers here, then why do you actually need to send these hello packets? So you will do one thing here. Okay, so the thing is that you shouldn't be, or the OSPF shouldn't be sending the hello packets connected to the LAN interface. At the same time, this network should also get advertised to the other router. For that, you will do a configuration called passive interface. You will do a configuration called passive interface. So the passive interface configuration is done to the interfaces connected to a LAN. Getting it? So that the LAN, they will not send the hello packets through the LAN. At the same time, the LAN will get advertised, the LAN network will get advertised to the other routers. So to do the passive interface configuration, we'll go to the OSPF. We'll go to the OSPF, router OSPF 100, we'll go inside the OSPF and we'll execute the command like this: passive interface fast Ethernet 0/0. This is the command to configure a network or an interface as passive interface. Clear? Done. Almost done. Then only the last config remains. Okay. Now, if I mention here, so I'm in R6. If I mention this in R6, what happens, guys? Any idea? If I mention passive interface F0/0 as passive interface, then what will happen? Any idea? It's not no broadcast, let me tell you. So the R6 will start sending the hello. The R6 will stop sending the hello. That means the neighborship will go down. Shall we do it? Yes or no? Yes. Okay. So now let me just say here, let me just capture the packets. So before, say, configuring the passive interface, let me show it to you. You can see the OSPF. Yes, R6 is sending. You can see R6 is sending the hello packets. Again, R6 is sending the hello packets. They are sending the hello packets. Now, after configuring this one, passive, of course the neighborship will go down. You can see all the neighborship, it has went down. OSPF adjacency change, it has went down. And now when you check it, can you see any hello packets? Of course you can see the hello packets from 10.0.0.4, 10.0.0.5 and all, but can you see the hello packets from 10.0.0.6? No, because 10.0.0.6 has stopped sending the hello packets, because we have made it as passive interface. So through the passive interface they will not be sending the hello packets. Clear? Okay. Yes. Okay, that is something else. That's the update and okay. Now, so this is the passive interface configuration. Now the last thing about Ospf. Okay. Now suppose, let me take this also. Suppose that in R7 we have configured R7, and to the right side of R7, F0/1 of R7, an IP address is configured 20.0.0.1/30. Let me check whether I have configured it or not. I think I may not have configured. Let me check it. So do show IP interface brief include 0/1. No, it's unassigned. Okay, so let me assign it and let me make the interface up. So the interface fast at 0/1 IP addresses, say what was the IP here? 20.0.0.1 and the other end is 20.0.0.2. So 20.0.0.1 255.255.255.252 and let me give no shutdown also. Okay, now the interface will come up. Okay, then let me go to R8 and give the IP. So this interface is faster than say the same interface, faster than 0/1. So R8 interface faster than 0/1 and IP addresses 20.0.0.2 is the IP, 255.255.255.252 and let me give no shut. Done. Okay, then the interface will come up. Now guys, you can listen here. Suppose this is the internet connection that I have taken. Internet in the sense, this is our organization. Okay, now from R7 I have taken an internet connection, or from the R7 I have connected to my internet service provider. Okay, then if you connect the internet service provider, so suppose this R8 is the service provider, internet service provider's router. Okay, then suppose if we got a LAN here, if we got a switch and we got multiple machines here, then suppose these computers are say searching or they are browsing the internet. Say suppose one guy is searching Google, one guy is searching Yahoo, one guy is say browsing in internet, so suppose like Twitter, and another guy is browsing Facebook, and another guy is watching YouTube, like that, right? So they'll have different IPs. Now say they will be sending all these packets to the gateway, right? Sorry, and who is the gateway? R7 is the gateway. Now R7, he needs to forward all the internet packet to R8. Whatever is the unknown network, whatever is the Google is the unknown network, Yahoo unknown network, Twitter unknown, Facebook unknown, YouTube unknown, whatever be the unknown network, just forward it to R8. Okay, so that means you will configure the default routing in R7. Shall we configure it?
Yes.
Okay, so let me configure the default route in R7. We'll go to R7 and we'll configure the default route. Okay, so IP route 0.0.0.0 again 0.0.0.0, then we'll give suppose the next hop IP which is 20.0.0.2. So 20.0.0.2. So all the unknown packets will be now forwarded to the internet service provider. Clear? Now, what if in R4 also you have multiple computers? Okay, and those computers also, say from those computers also they are trying to access the internet. Then you will have to mention the default route in R4. What if there are users in R5? You will have to mention the default route in R5. What if there are users in R6? You will have to mention the default route in R6. In all the routers you have to mention the default route manually, right?
Yeah.
Right? Okay. Yeah. Now, so if you have 100 routers, you need to mention manually in all the 100 routers. That is difficult. right? So this static route can be, say R7 has this static route. R7 can be configured in such a way that this static route can be injected into OSPF. The static route in R7 can be injected into OSPF and can be shared to all the routers via OSPF. You don't have to tell it manually in all the routers. The OSPF will advertise it to all the routers. Clear? So shall we do that? Okay, so what we are going to do is the statically mentioned route in R7, we are going to insert it into, or we are going to inject it into OSPF, and we are going to share it to all the routers. For that, we'll be doing a configuration called default information originate. So we'll go to R7. We'll go to R7. Just give me a minute. Okay. We'll go to R7 and then we'll mention the command like this. Just again give me, yeah. So the R7, let us see, do show IP route. The R7 has got a default route now, which points to the internet service provider. So this default route is static default route. This default route should be injected into OSPF and need to be sent to all the routers. So what I'm going to do is I'll go to the OSPF router OSPF 100. Then I'll mention the command like this: default information originate always. Okay, or default information originate also you can give. Okay, so if you mention this command, what happens is that, say R7 will send it to, so here the DR, who is the DR? R3 is the DR. So he will send it to R3, and R3 will send this network information to all the routers. So now if I take the packet capture here, where is the packet capture? You can see, say you can see this R3. So yes, R3 has sent a route. Okay, you can, when you check it, you can see ls update packet, not this one guys, just give me a moment, not this one. I suppose this is not the packet capture. Seven, then sorry, 6. Okay, suppose, just give me one more minute. Let me again say suppose stop capture. I'll capture it again because, okay, and I'm not sure. Okay, so let me go to the OSPF and again give no here. Okay, so let me capture it here. Start Wireshark. Okay, I had to start Wireshark, which I didn't do it. Okay, so now that if I go and do this in the R7, default information originate, then now you can see, yes, okay, R7 has sent something to the, say this one, okay, this 224.0.0.6, that means it is sent to the DR. Now it is sent to the DR and it consists of the default route. Okay, when you check it, it says LSA type 5, it is an external route, because for R7 it is an external route. It is mentioned statically. So if at all you are inserting or if you are injecting some static routes, then that is the external routes. That's called external routes. So the external routes are sent via or send as LSA type 5. Okay, and you can see the link state ID is 0.0.0.0 and the net mask is 0.0.0.0. That means it is the default route. The default route, of course, you know, it is 0.0.0.0/0. Okay, so this is now sent to this one, this guy in the sense it is sent to dr. Now dr, who is r3, will send it to everybody else. So here R3 will again send it to everybody. You can see the link state ID is 0000 and the den mask is also 0000. Okay, now when you take a look at all the routers, suppose R3, when you take, or say suppose when you take a look at R4, so do show IP OSPF or do show IP route. You can see the default route he has got it. Right, say the R4 has got a default route. How did he get it? He got it from OSPF. The O says it's from OSPF and the star says it's the candidate default. So that means that's the default route. Then E2 means the external. Where is the external? E2, OSPF external type 2. That means these are the external routes. Clear? Any doubts in this one? Or any doubts in OSPF?
You have to manually configure OSPF in all the routers or some other command.
Yes. But still, of course, you need to manually configure the OSPF in all the routers, but still it is better than the static route. Right?
Suppose so many routers in the online.
Of course, and that is why we have come up with a new concept called SDN, software defined networking. So if you have 100 routers, then you will have to configure all the 100 routers with OSPF, right? But still it is far better than the static route. But now even this is also considered as difficult. So what they have come up is that they have come up with something called software defined networking, which will make your work further easier. Okay. Yes. Any other doubts? And by the way, Srikanth was Srikanta was having some doubts, right? I suppose that it was Srikanta, right? You were about to ask something about your office network or some work related things or whatever.
No, the thing is that I have installed a router.
Okay.
Everything is working fine, perfectly all.
Okay.
But somehow I am not able to get the remote access of that.
So is the OSPF that you have done it?
No, protocol is something different.
Okay.
BGP is running.
BGP. Okay. Then check for the TCP connectivity. If you have got the TCP connectivity, obviously, then check for the like BGP connectivity.
BGP is working fine, sir. Because when we shifted the traffic, because primary is working fine and we have the control over it.
Okay.
So when we shut down the WAN circuit of primary,
Okay.
so by design, the traffic will shift to secondary.
Okay. Then
We are working on the secondary router.
Yeah.
So traffic was traversing through that. We can check from the tools, but we are unable to take the control. I have tried removing all AAA, TACAS and line BTY, all passwords we deleted. Then also again we configured from the console, from the field engineer. But nothing happened. I don't know.
maybe something is blocking there. Say some device might, maybe firewall or something might be blocking the remote access. You can check that for that. Okay.
Okay.
Yes. So anybody else have any doubt?
Yes, sir. This is Satish.
Yes, Satish.
Yeah, I have another doubt. Like, if you want to erase all the files in NVRAM, like, we have to make the router erase all the startup configuration. Then, is there any command available for that?
Of course, if you want to erase the startup config, erase startup-config is a command.
What's the command there?
Erase startup-config. So let me just show it to you here. Erase startup-config. Okay, and then you can reload the device. So when they reload, they will ask whether to save the config. Do not save the config.
Okay.
Okay. Then
So that means it erases all the files in the NVRAM, like that.
yes.
Oh, okay. Sir.
Anything else? So when I ask you about any doubts, I expect the doubts from these topics only. Okay, but still, if you have any other doubts also, you can ask. So any doubts from OSPF? Anyone? Yeah, Kevin?
Uh,
No?
Now, no, in future.
Okay, if it will come, you can ask.
sir,
Yes?
sir, 224005 is to communication for the all OSPF routers in between, right?
Yes.
And 224006 is for only DR-BDR communication, right?
Yes. Only, I mean, all the machines to DR. All the machines to DR.
Okay, okay, okay.
And the same thing, DR to all the machines also. You can see both. Okay. So here you can see, say 10.0.0.7 has sent to 224.0.0.6. It's actually, when you mention 224.0.0.6 here, so here, so 10.0.0.7, 10.0.0, say whatever. Okay. So it is actually sent to the DR only. 10.0.0, say 5 is sending to DR, 10.0.0.7 is sending to DR. It will reach all the routers, but again the thing is that, say the routers, if it is not required for them, they will not consider it. Okay, so you can say it is for the DR only. Study like that, for DR only. Okay. Yes. Anything else? Ritik? Naresh? Fine. So what about the online guys? Lot of guys we can see. Alok, Lakshit, Satish, Vijesh, Srikanta. Everyone fine? Till here.
As of now.
Yes, sir, fine.
Okay. Because we have completed the routing. That's why I was so we have completed one section here, big section here, the routing section. Okay. So tomorrow onwards we'll start switching. Okay. Yes. So thank you guys. Then we'll start switching tomorrow.
So once switching is completed, then as per your recommendation, we can start the lab, right, sir?
Yes, once switching is completed, but after switching also we got some miscellaneous topics and all.
Okay.
Of course, it will take some time for us to finish. Okay. Maybe 10-15 days. Within 15 working days will come. Not 15. Okay, maybe 10 to like 11-12 working days will
By
take.
the end of this month, I.
End of this month maybe.
Yes, yes.
Okay.
Okay. Okay, sir. Thank you. Thank you so much.
Okay, thank you guys then. Hmm? Sorry? Okay. Our batch started in the beginning of this month only, right? Then maybe by second or third. Second. Okay, second our batch started, so most probably by next second or around third or maximum by sixth and all we'll finish it. It won't take much time. Sixth and all, it won't go till sixth. I'll try it by maximum to complete it before. Okay.
So after 6, is there any gap or something?
Yeah, after 6 might be if at all the lab is pending, I'll give you the lab.
No, actually, I'll start the CCNP, so that's why I'm asking.
Yeah, of course you can just start CCNP. But say if you want to start, then I suppose that Srikant is already like experienced, right? Then you might not say do this live router access and all. This is actually meant for the freshers. Okay. So because even if you want to do it, you can also do it. But still, say you might have already done it in the routers, the real routers and all. Okay.
Yeah, the thing is that, frankly speaking, whenever you do